Alright, today we're going to be looking at quotient rule. Quotient rule, and one of the questions we will attend to is right here as well. And for quotient rule, differentiation with quotient rule entails using when you see a rational value, a rational expression, that is fraction. You have a numeric, you have a function up and a function down. You always want to use your quotient rule. So let's just get right to it. Now, the quotient rule, remember you have a u over v. The numerator is u and the numerator is v. Then you want to express it in this term. u prime negative u v prime all over v squared. Now this is our u and this is our v. So first I want to state your u is what? 3x negative 5. Your u prime is going to be differentiate. This you get what? 3. The next one is what? V. Your v is what? 7x negative 4. If you differentiate v, you're going to get what? 7. Now we can enter every of the values here. Here what do we have? We have v first. So v is what? 7x negative 4 multiplied by u prime. U prime is what? 3. Negative. Then we go to the next one. U, what's our u? Our u is 3x negative 5. So we write it 3x negative 5. All multiplied by what? V prime. V prime is what? 7. All over, all over what? V squared. That is 7x negative 4 all squared. So we open the bracket by multiplying. So 3 times 7x, we're going to get what? 21x. 3 times negative 4, we're going to get negative 12. Then we come here, there's a negative here that affects every of this. So 7 times negative 3, we get negative 21x. Then negative times negative is positive. 7 times 3 is what? 35. So we have positive 35. All over whatever we have here. 7x negative 4. All squared. Please always remember to keep the denominator the way they are. So we have positive 21 cancelling out with negative 21. 35 negative 12 will leave us with what? 23 over 7x negative 4 all squared. Now this is our answer to this question. Alright, so we have another question here. But this question, we could call this question a chain rule question. But we are going to use quotient rule inside because we have a rational expression inside. But the we're going to use a chain rule because we differentiate the outer part multiplied by differential value of the inside part. So if I want to take this, I will look at the whole of this like x. If the whole of this is x, so I can say if I differentiate this, we're going to get what? 4x raised to the power 3. Then we'll now differentiate x, which is this that we have inside. So let's get down to it. So the first one to differentiate is, so it's going to be what? Going to have what? 4 into, that is what? Divide the x. Divide the x is going to be what? 4 into 2x negative 3 all over 4x negative 5 raised to the power 3 times we differentiate what we have inside. Now differentiate what we have inside. Remember we have it's a quotient rule expression and we have u over v. First thing we want to state your what? Your u. Your u is what? 2x negative 3. Then your u prime is going to be what? 2. Then go to your v. Your v is what? 4x negative 5. Then your v prime is going to be what? 4. So having this formation, we can enter it. Remember the formula. We can write the formula here. V u prime negative u v prime over v squared. So we can write that formula out. So let's go. What's our v? Our v is what? 4x. Let's write it here. 4x negative 5. All multiplying what? U prime. Our u prime is 2. 2. Negative. Then we have our what? U. Our u is what? 2x. 2x negative 3 into bracket what? V prime. V prime is what? 4. Our V prime is 4. So now we write all over what? What's our V? Our V is 4x negative 5. So our 4x negative 5 all squared. So if we open this bracket up, we have 8x here. Here we have 8x. Then this is negative 10. Then this is negative 4. Negative 2x times 4. We have negative 8x. Then positive. Negative times negative is positive. So 3 times 4, we have a 12. Positive 12 here. All over. Remember, keep your denominator the same. 4x negative 5. All squared. You want to always keep your denominator the same. Let me clean this place. Clean this place. Thank you. We want to write this downwards. So we're going to have what? 4 into brackets. At this point, I'd like to keep the powers to themselves. So I'd like to say 2x negative 3. All raised to the power 3. Then what? 4x negative 5. All raised to the power 3. That's what we are doing. That's what we are doing. Now I can cancel 8. Remember, we're multiplying. So 8 negative 8 has gone. We're left with what? Negative 10 plus 12. That is a 2. So now I can write it here as 2. Now, before I write that, look at our denominator. We have the same values here. This is raised to the power 3 and this is raised to the power 2. I could express them in terms of if I have an x cubed times x squared. Add your powers. You will have x equals to 3 plus 3 raised to the power x raised to the power 3 plus 2, which is x raised to the power 5. So instead of having these separate terms here, I could bring them together and have a single term, all raised to the power 5. So that's what we're going to do. We have 4 into bracket. We're already multiplying by 4 times. Let's keep here. We have what? 4x negative 5 all raised to the power 5. Then we have this. We have 2x negative 3 raised to the power 3. Then we have what? Times 2. So right now I could say 4 times 2 is 8. Then round by values of, remember, it's all dy dx equals, now we have what? 8 into bracket 2x negative 3 all raised to the power 3 all over 4x negative 5 all raised to the power 5.